Okay, for the engineering mechanics, introduction, engineering mechanics defined as the science which consider the effects of forces on rigid bodies. Two parts, statics, second is the dynamics. What is the difference between the two? When you say statics, it is considered the effects and distribution of forces on rigid bodies, which are and remain at rest. While dynamics consider the motion of rigid bodies caused by forces acting upon them. Then we have the engineering mechanics. Of course, we have statics and dynamics. Under the statics, there are two parts, the force system and the application. But under the force system, we have the concurrent, the parallel, and the non-concurrent. While under the application, we have the trusses, the centroids, and the friction. While under the dynamics, we have again the two parts, the kinematics and kinetics. Under the kinematics, we have the translation, rotation, and plane motion. While under the kinetics, we have the translation, rotation, and plane motion. For the fundamental concept and definitions, when you say rigid body, it is defined as a definite amount of matter, the parts of which are fixed in position relative to each other. Solid bodies are never rigid. They deform under the action of applied forces. In many cases, this deformation is negligible compared to the size of the body, and the body may be assumed rigid. Now, for the force, any influence that will set a body in motion, defined as that which changes or tends to change the state of motion of the body. Okay, characteristics of force are: one, we have its magnitude; second one, the position of its line of action; and the direction in which the force acts along its line of action. Now, for the principle of translation, principle of transmissibility of a force states that the external effect of a force on a body is the same for all points of application along its line of action. It is independent of the point of application. What are the unit of force? We have the pound. We have LB for the pound. Kip is kilo pound. That is 1,000 pound. Ton, 2,000 pound. And Newton. This one is Newton. N. Newton. This one is Newton. Newton. N. Okay. Then we have the force system. A force system is any arrangement where two or more forces act on a body or on a group related to bodies. When the line of action, all the forces system lie in one plane. They are referred to as being coplanar. Otherwise, they are non-coplanar. Now, for the forces whose lines of action pass through a common point are called concurrent. Those in which the lines of action are parallel are called parallel force systems. And those in which the line of action neither are parallel nor intersect in a common point are known as non-concurrent force systems. Now, for the axioms of mechanics, number one, the parallelogram law, the resultant of two forces in the diagonal of the parallelogram form on a vector of these forces. Number two, two forces are in equilibrium only when equal in magnitude, opposite in direction, and collinear in action. Then number three, a set of forces in equilibrium may be added to any system of forces without changing the effect of the original system. And number four, the action and reaction forces are equal but oppositely directed. When you say equilibrium, the summation of forces at x, all the forces lying at the x-axis is equal to 0, and summation of forces at y is equal to 0. Then we have the introduction to free body diagram. The given example is this one. If this one is the given, the reaction of this one, you have your tension here. course, the tension here is the same, pero this one would be the direction. Kaya we have the free body diagram at point C. At point C, the reaction would be for A, we have your P going to this point and your tension is this one. While the weight, always remember that the weight is always going downward. Okay, that this one is the weight. Okay, therefore, the free body diagram of Derrick, this one is the Derrick, you have the tension here, the weight here, and this one is the reaction at point D. Okay. You should be familiar with the free body diagram. Okay, now for the scalar and vector quantities, of course, you know that the difference between the scalar and vector quantities. When you say scalar quantities, quantities with magnitude only. While for the vector quantities, quantities with both magnitude and direction. Kaya we have under the scalar quantities which possess magnitude only and can be added arithmetically. While the vector quantities, quantities with both magnitude and direction. Such quantities can be combined only by geometric addition. Now, for the parallelogram law, the method of vector addition is based on what is known as the parallelogram law. The parallelogram law cannot be proved. It can only be demonstrated by experiment. It is one of the fundamental axioms of mechanics. One method of demonstrating the law is by means of apparatus shown in this figure. Okay. Tie three cords together and fasten the weight P, Q, and W to the free ends. Then you have the reaction P here, the reaction Q here. Of course, the resultant is the sum of your vector P and Q. But under the parallelogram law, you cannot add it arithmetically. You're going to use what? Okay, under the parallelogram law may now be stated as follows. The resultant of two forces is the diagonal of the parallelogram formed on the vector of these forces. Okay, you have now this one, the resultant, the sum of all the forces. Okay, well, for the triangle law state as a convenient corollary of the parallelogram law. If two forces are represented by their free vector placed tip to tail, the resultant vector is the third side of the triangle. The direction of the resultant being form the tail of the first vector to the tip of the last vector.